Hello class! This lesson is on area of a circle. Make sure you have your notebooks ready because we're going to take some notes. First thing I want you to do is title your page, and this is area of a circle. As you can see, I have a couple things to remember here before we even start, so let's go over those. The first thing we need to remember is what we learned today and yesterday, which is that the circumference of a circle follows this formula. The circumference is 2 pi r. And when we remember that, we should also remember where these variables come from. So if we can remember 2 pi r to find the circumference, which is the distance around the circle, right? That's the circumference. We know that the radius is any line from the center of the circle to its edge. So this line would represent the radius, and whatever that measurement is, it'll be equal all the way around, no matter where you do it. That's the first thing to remember. The second thing we have to remember here is going back to this idea of PEMDAS. We're going to be solving our equations in the order of PEMDAS, so we just need to remember parentheses and then exponents. Exponents are always going to come first when we're solving. And the last thing we need to remember is this idea of squaring. So if we have r squared, remember it's r times r. It's not 2 times r. So I want you to make sure you write down these few reminders in your notebook before we get started. Okay, so here we have the formula for the area of a circle up here, and this is definitely something you need to put in your notes. So the formula is area equals pi r squared. Now let's take a step back and just think about where this comes from. It actually comes from our basis of circumference. So I rewrote our circumference formula down here to remind us. The circumference of a circle is equal to 2 times pi times the radius. Well, if I want to rearrange this circle into something similar to a parallelogram, I could take all these pieces and rearrange them so that it closely resembles a parallelogram. So let's remind ourselves, the area of a parallelogram is base times height. So let's call this the base and let's call this the height. But let's also notice the distance from the center to the edge is our radius. Well, when we rearrange this circle, this distance from here to here is the radius. Well, when I've rearranged it, that's pretty similar to the height. And since I've taken half of the pieces, you can see the green pieces are on the top and the blue pieces are on the bottom. That's half of the circle. So now let's think about this in a slightly different way. Going back to our circumference formula, if I do some simple math and kind of manipulate this, if I divide by 2 and divide by 2, okay, to even out my equation, I see that my 2's cancel out and this invisible 1 comes up over here. So really what I have is this formula 1/2 c equals pi r. So this is saying 1/2 of the circumference. 1/2 of the circumference is equal to pi r. So when we rearranged our parallelogram, putting half of the pieces on the bottom, we can safely say that half of the circumference equals pi r. Okay, if we follow our area of a parallelogram, we're saying base times height equals area. Well, here we've just found different ways to represent our base times height. So we found pi times r times r. Well, like we said earlier, r times r is r squared. So this is where this formula comes from. Area equals pi r squared. Pretty cool, huh? Alright, now that we understand that, let's actually solve some problems. So let's say we're given a problem. The radius is 5 centimeters, and we need to find the area. Well, first of all, let's get a visual for this. So from the center point to an edge, r equals 5 centimeters. Okay, I need to remember my formula. Area equals pi r squared. This just becomes an algebraic formula where I need to plug in my information. So, plugging this in, I have area equals pi 5 squared. Now, think, PEMDAS, what comes first? The exponents come first, before multiplication. So, I'm thinking to myself, 5 squared, this really means 5 times 5. Okay? 5 times 5, 25. And then I'm going to drop down my pi. I'm not done yet. I need to represent pi with a numeric value. The most common one, which we all know, is 3 and 1400ths. So let's use that this time around. 3 and 1400ths times 25. Well, let's just do some math down here. Okay, and we also need to remember, ignore the decimal while you're doing your multiplication, bring it back at the end. Okay, so 5 times 4, 20. 5 times 1 is 5, plus 2 is 7. 5 times 3 is 15. Now I'm doing my tens place. I need a placeholder. 2 times 4, that's 8. 2 times 1, that's 2. 2 times 3, that's 6. Now I'm going to add these all together. Okay, so I'm going to get 0. 7 plus 8 is 15. 5 plus 1 is 6, plus 2 is 8. And 1 plus 6 is 7. Got a little tight down there. Okay, now I need to remember my decimal. 2 places over, so in my answer, 2 places over. I had to do it at the top because I ran out of space. So my answer is 78.50, and I can't forget my units. I started with centimeters. The area is still going to be squared, so it's going to be centimeters squared. So let's go back and write this properly. Area equals 78.50 centimeters squared. All right, let's do one more. Let's say our radius this time around is 3/4 of a centimeter. So the distance from the center to the edge is a fraction. 3/4 of a centimeter. That's pretty small. We still need to remember our formula. Area equals pi r squared. And we're still going to drop in our value, plug it in, just like we did last time. So the next line of our formula is going to be area equals pi times 3/4 squared. Now, when you're given a fraction, you need to keep it in a fraction form the entire time. So let's do the exponent first according to PEMDAS. We're going to do 3/4 times 3/4. So we need to remember how we multiply, which is straight across when we multiply fractions. 3 times 3 gives me 9. 4 times 4 gives me 16. Okay, so I have 9/16. The next line of my formula is going to be area equals pi times 9/16. In the last slide, we recognized pi as 3.14. Let me write that in a different color. 3.14. Well, here I have some fractions. The other way to write pi in fraction form is using the following fraction. 22/7. Make sure you write this in your book. This fraction equals pi, just the same way that 3 and 1400ths equal pi. Okay? These are the same thing. When you're given a fraction, choose the fraction form. So when we go back and write our next line of our equation, instead of using the decimal form, I'm going to use the fraction form, 22/7 times 9/16. So now I'm back to just multiplying fractions. I could multiply straight across, but before I do, I'm going to look and notice. I hope you guys notice what I'm noticing, and that I've got some even numbers here. So at the very least, I can divide by 2. Let's see where that takes us. If I divide the top by 2, okay, let me write it over here, divide by 2, divide by 2. So 22 divided by 2, that's going to give me 11. That's smaller. And 16 divided by 2, that's going to give me 8. That's smaller. Okay, so cross that out, cross that out. Now we're multiplying straight across. Okay, 9 and 7, when I look diagonally there, I can't do much. So we're going back to 11 times 9, straight across. All right, 99, got some big numbers. And then on the bottom, 7 times 8 is 56. I hope you know what I know and that we are not done. So let me shrink this, get some more space going here. We have to write our finalized fraction as a mixed number. So we are taking this and trying to find it as a mixed number, which means I need to divide. See how many times 56 goes into 99? Once. I know it can't go twice. Okay. Subtract 9 minus 6 is 3. 9 minus 5 is 4. This becomes the numerator in my fraction. So 43 over 56. Let's write it proper, okay? So answer, area equals 1 and 43/56 centimeters squared.